What's up, fellas? In this video, I'm going to help you guys review for the Unit 3 test. So I'm going to be doing some sample problems and going over some concepts that you need to know. Really, anything I say in this video is going to be pretty much on this test, unless it's a joke. See, that's also a joke. So, actually, that's true. It's not really a joke. Jokes won't be on the test. But moving on. The first thing I want to review are the scientists. Okay, so there's 4 scientists you need to know, and there'll be questions on all of them. There's Democritus. Hold on. Let's get my pen working here. Oh my gosh. Life. Okay. How do I do this? Draw with touch. Here we go. Okay. So the first guy that we learned about was, Balderdash. Okay. I got this, guys. Give me 1 second. Okay. Sorry. Okay, so Democritus is the first guy that we learned about, and he is going to be on the test. He was basically a Greek philosopher, okay, and he is credited with first coming up with the idea of the atom. So he's the one who first theorized. So he didn't actually discover it because he never did an experiment, but he theorized about the atom. And he called it atomos, A-T-O-M-O-S. But he theorized that there was this atom, and his main idea was that it was indivisible. So he said this atom, indivisible, cannot be divided. That's the BB gun pellet theory. So it's so small, it's a sphere, a hard, solid sphere that does not have separate parts. So he thought the atom was the smallest part of matter, okay? So a bunch of years later, so close, a little over 2,000 years later, the second guy comes along, and this is this guy named Dalton, okay? He came around in the 1800s, and he came up with 4 ideas. They're called his 4 postulates. Okay, first of all, I need to learn how to number because it doesn't go from 1 to 4. It goes 1, 2, 3, 4. It's because I was homeschooled, guys. Okay. So 1, 2, 3, 4. These are his 4 postulates that he came up with. The first was he said, and stole this from Democritus, the atom is indivisible. So he's like, okay, this guy, I think he knows what he's talking about. Sorry, my pen is just being annoying right now. Indivisible. Remember, that means you can't be divided. So it's a solid sphere with no separate parts. A solid sphere with no separate parts. That's the first thing he said. The second thing he said was all atoms of the same element are the same or identical. Okay, and then he said all atoms of different elements are different. And then the last thing he said was that atoms can be rearranged. Can be rearranged in a reaction, but they can't be destroyed. Okay, so these are the 2 that he got wrong. All right, the 3 and 4 are correct. All atoms of different elements are different. That's why they're titled different names. That's why they're different elements. It's because they have different properties. Specifically, all atoms of different elements are different because they have different numbers of protons. So protons are really the identifying factor of an atom. So if an atom has 4 protons, it's categorized as one type of element. If the atom has 5 protons, it's categorized as a different type of element. So protons are permanent. If they ever change, that means we're changing the element itself. We're no longer that element. So within a given element, the protons are permanent. So how did he get these first 2 wrong? Or how did we know that these first 2 were wrong? Well, this first idea, he said all atoms are indivisible. J.J. Thomson is the one who disproved him on this postulate, on this idea. J.J. Thomson disproved this because J.J. Thomson discovered the electron. And when he discovered the electron, what he essentially said was that the atom can be divided. It's got separate parts, and one of those parts is the electron. Okay, so J.J. Thomson disproved that. We also know that all atoms of the same element are not exactly the same because we learn about isotopes. So there's not a scientist you need to know, for who disproved this. You just need to know it's not true because of isotopes. So isotopes are atoms of the same element. So they all have, that means they have the same number of protons, but the only thing that's different about them is that they have different numbers of neutrons. Okay, so let's talk a little bit about isotopes and how to write them out. Okay, so there's two types of notation you need to know. There's isotope notation, and then there's name notation. And you're going to see both on the test. So isotope notation is when you have the symbol right here, and then you have three numbers. The number on the bottom is the atomic number, which is your proton number. Did I say the top number? I meant the bottom. The bottom left is the atomic number, which is also your proton number. The top number at the very top is the mass number, which is your protons and neutrons. It's not the average mass of that element, okay? It's the specific mass of that specific atom of that element. And then this is your charge. Remember that your protons minus your electrons gives you your charge. Okay, so that's isotope notation. It's a lot more complicated. Name notation is very simple. It's the element name. So whatever the name of the element is, so you pick carbon here or hydrogen or whatever, and then there's a dash, and then there's a number here. That number is the mass number. Remember, how do we know what's in the mass number? It's your protons plus your neutrons. Memorizing this will cover 70% of what's on the test. So you need to know, if I give you some of the stuff, so if I give you isotope notation, you're given mass, you're given protons, you can always find neutrons. So how would you find neutrons? You would take your mass number, you would use the equation, protons plus neutrons. If you have mass and you have protons and you're finding neutrons, you're just going to subtract your protons from both sides so that you can find your neutrons. So you have to be able to do that. You also have to be able to figure out how many electrons there are. You can easily figure out how many electrons there are because you know the proton number, right? That's the atomic number. So, and then you also know your charge. So you'll have your charge and you'll have your protons, and then you can use this equation to find your electrons. So let's try a couple of these problems. So if I give you something that says X 1932 plus 1, and I said how many protons, neutrons, electrons, what's the mass number, and what's the charge. You need to be able to find all of these things via this isotope notation. The first, the charge, is given to us right here, so let's write that in. The mass number is given to us right here, so let's write that in. And the protons are given to us right here. That's the atomic number, so 19. Oh, and I also want you to find the element. So the element's always based on the proton number, which is down here, okay? So on the periodic table, let me check for a second. Potassium. Potassium has the atomic number of 19. So this is potassium. So it's got 19 protons. Okay, so how do I find neutrons? Remember, when we're finding neutrons, we need to use this formula. Mass equals protons plus neutrons. So my mass was 32. My protons were 19. How do I find neutrons? Subtract 19 from both sides. So I take 32 and I'm going to subtract it from 19, and then you get 13. So we have 13 neutrons. Now how do I find electrons? Okay, so I have the charge. The charge is plus 1. So charge equals protons minus electrons. My charge is plus 1. My protons are 19. How many electrons do I have? So 19 minus what will equal 1? Okay, obviously it would need to be 18, right? 19 minus 18 equals 1. Another way to look at it is that there's one more positive charge than there are negative charges. So as you can see, 19 is one more than 18 because protons are the positive charges and electrons are the negative charges. Okay, I also need you to be able to do pretty much the same thing with just name notation. So if I give you the element name, Actually, let me give you the actual element. Let's do potassium again. So potassium 22. Potassium-22. This is not the atomic number. It's not the number of protons. It's not the number of electrons. It is your mass number. Super important. In name notation, the number after the dash is always the mass number. So I know my element. It's K. Okay. My mass number is 22. Let's find protons, electrons, neutrons, and the charge. So the protons for potassium is really easy. As long as I have the element name, I can just look on the periodic table and find the atomic number. The atomic number for potassium is 19. So my protons are 19. And then my neutrons are easy to find using the same formula. I'm given mass. This is my formula for mass. My mass is 22. My protons are 19. How do I find neutrons? You do 22 minus 19 and you get 3. So you have 3 neutrons here, which is actually really small. You should have more than that, but that's okay. So neutrons, 3 neutrons. How do we find electrons and charge? Well, we'd actually have to be given some more information here. I would need to tell you whether potassium 22 is neutral or whether it had a charge. Let's say that it was neutral. Let's say we had a neutral potassium 22. Neutral means that our charge is 0. So if we used our formula, charge equals protons minus electrons, 0 equals 19 minus what? So 19 minus what would equal 0? Well, obviously 19 minus 19 would equal 0, right? So our electrons are 19. Another way to think about it is, remember how I said in the other one, like the charge was like 1 more electron or 1 more proton? Well, if the charge is 0, that means there's 0 extra protons and 0 extra electrons, which means they're the same. Okay, they have the same number. So protons and electrons are the same if they're ever neutral. And our charge is 0 because it said neutral. Anytime it says neutral, the charge is always automatically 0. Let me think if there's some other things we could go over. You do need to know the location of everything. So in an atom, your protons and your neutrons are found in the nucleus. Outside the nucleus, we find the electrons. Electrons have a negative charge. Protons have a positive charge. And neutrons have a neutral charge. Okay, they don't factor into charge at all. You also need to know that protons and neutrons are the only ones that have mass. All the mass is basically found in the nucleus. Okay, each proton and each neutron has a mass of 1, which is why we can add them together to get the mass number. Electrons have no mass, they're massless, and so we don't factor them into the mass number at all. That's why the mass number is just protons plus neutrons. Let me see. One thing to know is how we got to this model. So we know that J.J. Thomson discovered the electron, right? He found the electron and disproved Alton's idea that the atom was indivisible. But Rutherford was the guy who discovered our nucleus and our protons. So what he did, I don't know if y'all remember, but he did the laser experiment. So here's the atom, okay, and he shot a bunch of rays through the atom like this. Most of them went straight through the atom, but a few of them deflected. And when they deflected, he realized, okay, these are positive charges, right? These are positive rays that are being shot. The only way a positive ray would change direction and come back is if it also hit something that was positive. So he deduced that the nucleus, which is right here in the middle, is positively charged. He also deduced that the nucleus was small. So the nucleus is small and positive. The reason why it was small is because most of the rays didn't hit it. Most of the rays went straight through. And then he also deduced that the rest of the atom is mostly empty space because, again, most of the rays just went straight through. So most of the atom is empty. The nucleus is very, very small and tiny. And in pictures, we kind of draw the nucleus kind of large, like in this first picture, but it's really not. It's super tiny compared to where the electrons are. Okay. Couple other things that you may want to review for the test. It's just some old topics. You want to review counting significant figures from your notes, you want to review how to write in scientific notation. You want to review accuracy and precision. So how can you decide if a set of data points are precise? You want to review that. And then you want to review how to find the independent variable and the dependent variable inside of an experiment. So these are a couple questions that you might see on the test that are like from previous units. So it's not a comprehensive test, but these 4 topics will be tested again on this test. So you may want to review those. And the 4 rules for sig figs are that all non-zeros numbers will count. Front zeros, so zeros in front of the first number, will never count. Middle zeros, like in between numbers, will always count. And then the last one is ending zeros will only count if there's a decimal. So it'll count if there's a decimal. Sorry, my handwriting's bad. It's kind of hard to write on the screen. And I guess that's it for our review. Please make sure that you continue to study. The game on the Build an Atom is a great way to continue practicing figuring out charge and protons and neutrons and electrons. Other than that, that is it for our video for review. Study, 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 and good luck on your test on Monday.